All right, today we are diving headfirst into the shadows. We're on a digital manhunt, chasing ghosts through the hidden corners of the internet. We're talking about the dark web and how investigators find the people who are trying their best not to be found. So that's really the big question, isn't it? The dark web is specifically engineered for anonymity. It's a place where you can disappear. So if you're an investigator, where do you even start when the entire crime scene is designed to vanish into thin air? Well, first things first, you have to understand the territory. In the internet that you and I use every day, that's really just the very, very tip of the iceberg. Okay, so let's break it down. You've got three main layers. Most of us, we live on the surface web. That's everything Google can find. Then you have the deep web. Don't let the name spook you. It's mostly just stuff that isn't public, like your online banking portal or your email inbox. But the dark web, that's a whole different beast. It's intentionally hidden, and you need special software to get in, all for one reason: total anonymity. So, how does this whole invisibility cloak actually work? Well, the magic behind it is a technology called Tor, which stands for the Onion Router. And trust me, that name tells you everything you need to know. Right. So imagine your data is a message inside an envelope. Onion routing takes that envelope and wraps it in layer after layer after layer of digital encryption. It's just like an onion. Each layer has just one instruction: send me to the next stop. Only when it gets there can the next layer be peeled away to reveal the next destination. So here's what that journey looks like. Your computer connects to the Tor network, and your data packet starts bouncing between random computers. These are called relays all over the world. By the time your request actually reaches a website, that website has absolutely no idea where you came from. All it sees is the IP address of the very last computer in the chain, the exit relay. And here's the brilliant part. From an anonymity perspective, no single point in that chain knows the whole story. The first relay knows who you are, but not where you're going. The middle one is just a blind pass-through. And the last relay knows your destination, but it has no clue who you are. That separation is what makes Tor so powerful. So you can see how this system builds a massive, massive wall for any investigator. From a forensics point of view, it is an absolute nightmare. Trying to catch someone in this environment, well, it's not just hard, it really pushes the limits of what digital investigation can even do. And the hurdles are just huge. The tech itself is built to hide people. The browser they use is designed to automatically cover its tracks. The suspects could be literally anywhere on the planet, which is a legal minefield. And, of course, the money they often use, crypto, is also designed to be anonymous. It is, for investigators, a perfect storm. But here's the thing. No system is ever truly perfect. Even the most cautious user, the most careful criminal, can leave behind these tiny, almost invisible traces, digital fingerprints. And a sharp investigator knows exactly where to start looking for them. Sometimes it all starts with something as simple as one command. Let's say an investigator gets their hands on a suspect's computer. The very first thing they might type is netstat-ANO, just to see if that machine is even talking to the Tor network. This command basically gives them a live look at all the computer's network connections. But the real magic ingredient here is that little O at the end. That flag shows the process ID, which is a unique number assigned to every single program running. And that lets an investigator directly connect a network port to a specific application, like the Tor browser. So what are they looking for exactly? This number, 9150. That is the default port that Tor uses to do its thing. Seeing traffic on port 9150 is like a giant flashing red light. It's a huge piece of evidence telling the investigator, yup, you're in the right place. Okay, so once they have a strong suspicion, the real digging begins. And because the Tor browser is built on top of Firefox, it has a kind of Achilles heel, a little database file called places.sqlite. You can think of it as a secret diary of everywhere the user has been. And this one file can be an absolute goldmine. I mean, inside, you've got tables that list every single website visited, a detailed log of when they visited, and any bookmarks they might have saved for later. It is a complete roadmap of the suspect's travels across the dark web. But what if you need to know what a suspect was doing, like, right this second? For that, investigators have to go after the most powerful, but also the most delicate source of evidence there is: the computer's RAM, its memory.
You know, in forensics, timing is literally everything. Evidence that's in a computer's memory is incredibly volatile. It can vanish in a heartbeat. What an investigator can find depends entirely on whether that Tor browser was open or closed at the exact moment they captured an image of the system's memory.
And the difference is? Well, it's night and day. If the browser is open when they grab the memory dump, they can see everything. The full text of an email being typed, who it's to, who it's from, even the attachments. But if the browser was closed just a few moments before, that data starts to degrade, and they might only get back fragments if they're lucky.
Okay, but what about the ultimate move, the cleanest getaway? What if the suspect doesn't just close the browser? They delete it, they uninstall it, wipe it clean. Is the trail completely cold then? Well, not always. This is where something called prefetch files come into play. These are tiny files that Windows creates to help your programs load faster. But for an investigator, they are the ghost of a program. They're a digital echo that proves an application was there, even after it's gone.
So what can this little ghost tell us? A prefetch file can prove the Tor browser was ever on that machine. It can show exactly where it was run from. It even has a little run counter that shows how many times it was launched. And most importantly, it gives you a timestamp for the last time it was ever used. The browser might be gone, but its shadow remains. So in the end, there's really no single magic bullet. Catching these digital ghosts requires a whole toolkit. Investigators have to combine network analysis, deep dives into browser files, live memory captures, and sifting through system artifacts like these prefetch files just to piece together the entire story. Which of course brings us all the way back to that first big question. The tools for privacy and anonymity get more sophisticated every single day. But so do the tools for forensic investigation. It is a constant technological arms race. So, in this endless game of cat and mouse being played out in the darkest corners of the web, who do you think is actually winning?